Whatever white
Yes,
screen
yes.
is visible.
Yes,
Is white
sir.
one?
Loading. Yeah, why?
Yes, sir, visible. Math one.
I am not able to
On the
share
screen.
my. Yeah, no. Is the one more thing is visible to all? No.
No, sir.
No.
No.
Yes, yes.
Now visible.
Okay. Okay. So I am writing here what are the doubts do you guys have? Okay. Let's start the class. Okay, so someone. Okay, so first one is subsequence part, right? Subsequence. And apart from that,
Yes, sir. Limits of functions, like one or two questions and one concept.
okay. Limits of functions. Anything else? Anything else apart from that?
No, sir.
No. Okay. Okay, let's start with sequence firstly. Okay, what is sequence? And then we will slightly like we will try to move towards subsequences and then limits of a function. Okay, and then we will take some examples and all. So, for
Yeah.
example, what we will do basically, we will take your example from the practice set or whatever assignment sheet you have. Okay.
Oh,
Okay. So, will it be fine for everyone? The strength is too low, but yeah, still we will try. Will it be fine for everyone? Please
yes, sir.
let me know if is there any topic that you want me to explain. You are feel free to ask. Okay. If you are not going to ask, then I will think that yeah, you know that concept, and I will move forward. No YouTube link in calendar. Can someone please check on YouTube whether this session is streaming or not?
Yes, sir, it is streamed.
Streaming, right? Please paste that YouTube link here. Yeah, someone has pasted. Okay, let's start. Let's start with sequences. Okay, what is sequences? So, firstly, we will study what is sequences like. Is there anyone who has any idea about sequences? What is the dictionary meaning of sequence?
Like arrangement of numbers of something.
Arrangement of numbers.
Continuous
In
elements.
general, I'm not talking about numbers and all. In general, what is the meaning of sequences? If I will say
Like
you, yeah, this
arrangement.
is the bunch of
Arrangement of some things in an order.
yeah, exactly. It's, arrangement of something in order, right? So what is it basically? What we will do basically? Suppose I have something in this box. Okay, something, I don't know what is it. I have something, or I will say, yeah, there are some balls. Okay, there are some balls and all, or you will say bulbs, whatever it is, like something are there in this mystery box. Okay, so what I will do, I will assign some places like this, like this, like this, like this, like this. Have you like I hope everyone went their school. So in the school, have you seen the line process, like where you have to do prayer and all? So there will be
Yes.
some arrangement, right? Sir, some standard limits like that tends to E, and how to use them for solving limits. Okay, okay, I'll do here. Okay. Yeah. So did you seen that kind of thing? Like whenever in the early in the morning we will go to the school, and then before attending our classes we have to do some prayer and all. And for that we have to make a line kind of thing, like the first attendance student will be sit on that line, second standard is student will be stand on that line, and third, fourth, like that, right? Right?
Yes.
Or
Yeah.
forget about it. Forget about it. Whenever you will go for exam, like the quiz one that you have done. So you went to your respective, sir, I have a doubt in graph and tangent. Okay, we will discuss later. Okay, Surat. Okay, so whenever you went to your respective centers for giving this IIT-based program quiz. So what you have seen, everyone have assigned some roll number, right? Right?
Yes, sir.
Yes, sir.
Everyone has assigned
Sir.
some roll number, and according
Yes,
to roll number, your places was assigned, right?
Yeah.
Yes, sir.
Yes, sir.
Right. So what? Yes. Yes. Please. Fine, no? So what I am
Yes, sir.
saying?
Fine.
What I am saying? Suppose this bucket has all the IITM BS program student, and what I have done here, I have assigned some numbers, some natural numbers, some natural numbers to them, right? And according to that numbers is known as roll number for your case. Okay, so according to that number, I have assigned some places. Suppose this is for first roll number, this is for second roll number, this is for third roll number, right? Right. So what I have done here, I have assigned some places for this bunch of elements, or for this bunch of products, whatever I have in this mystery box, right? That I
Yeah.
think, and according to that, if they will go for the exam, so according to this number, they will sit on their places, right? Right.
Yes.
Suppose
Yes.
first person is Suraj. Suraj sit here. Another one is suppose what to say, Manoj. Manoj sit here. And this roll number is belongs to me, so Arpit will sit here, like that. So what is the observation here? Observation here is that whenever I just want to I want to arrange something, I need to assign some number, right? I need to assign some number like this: first place, second place, third place, fourth place, like that, right?
Yeah.
Or you have seen in the attendance sheet, like in the classroom, teacher will call by roll number, so they will say roll number 1, then you will say present sir, like that kind of thing. So what thing is going on there? There you have assigned some number, or you can see your Aadhaar card as well. Aadhaar card is what? According to that Aadhaar card, they assigned some number, right? So for government, you are just a number, that kind of thing. So that number will identify you, right?
Yes, sir.
Right? So in this
Yes,
case, whenever I will say, please call third person. So what you will do? You will call me, right? You will call to
Yes.
Arpit.
Yes.
If I will say call second person, what you will do? You will call Manoj.
Yeah.
So identity of this particular things is right now is known by this number, right? First, second, third, and fourth, 5, 6, 7, 8, right? According to that.
Yeah.
Now, one more observation is that if I am calling for third person, this Manoj cannot go. Right?
Yes.
If
No,
I
sir.
will call third person, this Manoj will not go.
Mhm.
So basically what I am doing, I have some natural number except 0 set, and I have some another set S. So what I am trying to do, I am just making mapping, right? I am just making a function from here to here, right? Suppose this is function f. So I will say, yeah, this ff1, for this case, this is what? Suraj. This is f of 2. And for this case, this is what? Manoj. This is what? Arpit and all. So what I am doing? I am defining a function from natural, like I will say this set as natural number currently. Okay, forget about this 0. Forget about this 0 right now. Okay, so what I am doing right currently, I am just defining a function from this set to this set, right? Now observation is that this s can be different, but this whenever I want to assign this kind of places, I need this number, right? Always in the domain.
Yes, sir.
I cannot say that Suraj will sit on the 0th place. I cannot say Suraj will sit on the -1th place, right? Right?
Yes, sir.
So this kind of arrangement, this kind of thing, whenever I will assign some number to some set. Okay, so one more thing. If suppose I am assigning 250 numbers from something, suppose Mr. John. So what is it? Before this 250 student, there was 249 student, right?
Yes.
So what this implicate? Like each element of this n minus 0 set have some image on this S, right? So what is sequence basically? Sequence is what? Sequence is a function from this to this S, right? Sequence is a function. From natural number to S. Okay. And this kind of thing is known as sequence of this set S. Okay. So since okay, so what I am trying to say, I am just saying, like since it's a function, so we will have some image, right? F1, F2, F3 kind of thing. Like that, f of n and all, right?
Yeah.
Yes, sir.
Right. So in the and the what is the like where they're belonging? They are coming from your set S, right?
Yes.
Right. Now I will rename it. I will say this one is x1, this one is x2, this one is x3, this one is xn. And according to that, I will say these xi's are coming from this S. Okay. Where f of I is nothing but xi. I just rename it. Okay.
Yeah.
Okay. So this function, which is also denoted by this xn. Okay. This is called as a sequence of S, set S. Understood up to this? No issue. So what is sequence basically? Sequence is nothing but it's kind of arrangement. What kind of arrangement? Or in a way we will see that the sequence is nothing but it's a function from natural number -0 to something, some set. Then in this case we will say this particular thing, this function is known as sequence of that set. Okay, because I am arranging the element of that set. Okay. Understood up to this? Now, if I will take S is equals to R. Okay, if I will take S is equals to R, then in this case, this sequence is known as, in this case, this sequence is known as sequence of real number. Sequence of real numbers, and that thing you have to study. What is sequence of real number? Now, understood up to this? What is sequence of real number? Sequence of real number is nothing but it's an arrangement of real number. Okay. First of all, it's an arrangement of a real number. So for defining this kind of thing, what we will say? It's nothing but it's just a function from natural number minus 0 to real numbers. Okay.
Yeah.
Okay. For example, let's take f of okay. Let's take Sn is equals to, or Xn is equals to 1 by n. This is also a function, right? So what are the elements? This is a sequence whose nth term is this. So what kind of sequence it is? 1 for n is equals to 1. For n is equals to 2, it is 1 by 2. For n is equals to 3, it is 1 by 3. For n is equals to 4, it is 1 by 4. Like that. Okay. Understood up to this? Okay. One more thing.
Yes.
Since this place is known as first place, this is known as second place, this is known as third place, this is known as fourth place, this is known as fifth place. So whenever I will call you, what is the element of kth place? So what it will be? It will be 1 by k. Right? It
Yes,
cannot be
yes.
1 by 5, it cannot be 1 by 4, it cannot be 1 by 3. If I am calling for kth place, it will be 1 by k only. Or if I will call you call for fifth place, so it will be 1 by 5 only. Right?
Yes, sir.
Yes.
Now, since the places of this each element is different, Okay, so one more example is that suppose I have a sequence like this, 1 1 1 1 1 1 kind of thing. Okay, so if I will ask you whether this one and this one both are same or not, so what is your answer? If my
No.
question is it's not same, why?
Because both one represents the is at the different positions. Like that one is
Yeah.
the first position, that one second.
Okay. Okay. So what is our observation? There is the possibility that if I will see the number individually, that number will be same. But we cannot say that this number will can sit here as well. Okay. Because of their places is already predefined. The places are already predefined. So we cannot shift the number. Okay. We cannot shift their places. No matter the number will be look like same. It's just like suppose in your home you have a in your hand you have iPhone. Okay, iPhone 15 Pro Max Ultra, whatever you think, but same model phone. And in another person hand, the same model will have that on the for like with that person as well. Suppose I have iPhone 15 Pro and Suraj also have iPhone 15 Pro. Both mobile brand and their models are same, right? But the owner of different, right? So we cannot interchange our mobile, right?
Yeah.
Right? Whether they are manufactured in same company, they are behaving like same, they have same qualification, whatever it is. But since the owners of those two mobiles are different, we cannot say that yeah we can interchange the mobile, right? That's kind of thing is happening here. Okay, now what is subsequence? What is subsequence? So subsequence is basically, since here we have seen that first place, second place, third place, this is an increasing order, right? We are not starting third place, then first place, then second, fourth place, then second friend. That kind of thing we are not doing, right? We have already decided the places, and according to these places, we are putting some numbers, right? And this places is in increasing order.
Yes.
Right? We have already decided a sequence. We have already decided their places, and the places, whatever we have decided, it is in increasing order. The first place, second place, third place, fourth place. It is not like third place. Firstly, we are considering third place, then we are considering first place, then we are considering second place, then fourth, sixth, seventh. That kind of thing is not happening here. Okay. Now, so what is subsequence basically? Subsequence is nothing but what we are doing. Suppose I have this sequence. Okay, I have a sequence which is already predefined. So since we are saying subsequence, just like subset, it is kind of sequence, right? Subset is what? Basically, it's kind of set which is coming from another set, right?
Yeah, right.
Just like subset, because here I am using subsequence word. So what we can say, we can observe here that it will be a sequence, and this sequence will come from the original sequence, right? Right?
Yeah,
Okay, so what
right.
thing I have in this case? What are the things that I have? Here also, since it's a sequence, I have to decide what is first place, what is second place, what is third place, right? That thing I have to decide here as well, and according to that, right? So which element will sit here? That I need to decide, right? But what are the element I can take? I can take here from here only, right? Right? So now how will I decide? How will I decide which element will sit here? So what are the element will sit here? It's up to you. Okay. But the thing is, suppose I am giving this second position. I am giving this second position as here. So I will put 1 by 2 here. Now I have eliminated this, so I cannot go back. I have to move forward because this is an increasing order. I cannot back move, like I cannot go back. Okay, so I have to go move forward. So here I cannot choose first place and second place because second place I have already choose. So I cannot choose first and second place. So for that I have to go third place, fourth place, fifth place, and all that kind of thing. So in this sequence for second place I am choosing suppose fourth place. So what it will be? For fourth place, it will be 1 by 4. Now, up to this, it is already clear. So I cannot use up to this. So I have to decide for 1 by 5, 1 by 6, 1 by 7, 1 by 8. Right? So what is basically, what is the idea basically? I have to move forward. I cannot go backward. Okay? Because of this increasingness kind of thing. Getting my point?
Yes, sir.
Got the idea? So what I am doing, suppose I have another sequence. Suppose I am saying my sequence, which is xn, whose nth term is this n. So what will be the sequence? The sequence will be look like, okay, 2n. So the sequence will be look like 2, 4, 6, 8, that kind of thing. Now I just need to define a subsequence. So what are the we have infinitely many subsequences. Okay, so I am giving you some subsequence, and then please let me know whether this kind of thing are subsequence or not. Okay, for that I am just giving you some sequence. Okay, just let me know which one is correct. There may be more than one correct answer, but yeah, let me know which in this kind of thing.
The second and third.
Second and third. Okay, why first? Why not first?
So because here 4 and after 4 and 12 we have taken 10, which is not valid.
Why?
So because if we take the 4 and 12, then we cannot get back. We
Yeah, we
have to
cannot
go.
go back, right?
Yes, sir.
We cannot go back because for four, I can take some elements from after this 4 only, right? I cannot go back. And also, once I have picked this 12, so I cannot go back. I have to go move forward. See, here I am not seeing their functional value. Okay, here I am not seeing their functional value. What I am seeing, I am seeing the places. First, second, third, fourth, fifth. I am just seeing the places. Here I have choose for first place. I have choose this second element. Here I have choose what? For this second place, I have choose from here sixth place. Sixth place element I have choose. So since I have choose this sixth place element, I cannot go back. but this 10 is coming from 5th place, right? So this cannot be my subsequence, right? Since
Yes,
this
sir.
10 is
Yeah.
coming from 5th place, and before this 10, I have already chosen this 6th place. I have already choose this 6th place, so I cannot go backward. I have to move forward only. So this cannot be my subsequence. Now, what about this?
So this is a
This is
subsequence
why? Because here
because it follows.
it follows the rules, whatever we have made here, right? So what are if you see
Yes,
here,
sir.
this is coming from 1st place. This is coming from
4th place.
4th place. This is coming from
8th place.
8th place, and this is coming from 16th place. And according to
Yes.
that, this will happen. Now, what about the third one? So this is the subsequence.
It is also
This
a
is the sequence
subsequence.
itself.
This is a sequence equal. So from here, what we can see here also, this is coming from 1st place, this is coming from 2nd, this is coming from 3rd, this is coming from 4th. So what is observation here? This is also a sequence because this is not validating my whatever concept we have, what are the rules we have decided. So this is not violating that rule. So this will become a sequence. So from here we can see that every sequence is also a subsequence of itself, right? Right. So this is the observation that we have seen here. Okay. What about this 4th one?
No, sir, not a subsequence.
Why? Why?
Because in option 4th we have 3rd place 3, which is not occur in our original sequence.
Okay. What about this one?
One also not
Yeah,
there.
1 also.
Okay. So this is not a sequence because since so this is a sequence, this is not a subsequence. Okay. Why it is not a subsequence? Because here I have seen that for subsequence of this original sequence, the elements should be appear from this sequence only. That I cannot take some elements from outside. Okay. Understood what is the concept here of subsequence? I hope everyone should understood. Is there any doubt here? Okay, so my question is how many subsequence I can create from a sequence?
Right.
Infinitely many.
Infinitely many. Why?
So, because it depends upon us to how we take,
Okay,
how we
so
assign
it
the places.
depends. Yeah, it 4th option again. Okay, so this one is not a subsequence because if it is a subsequence of this original sequence, then all the elements what are the coming here, they have to be from this set only, no? Sir, explain subsequence thing one more time. Okay, I'll explain. Okay, so since one is not coming from this original subsequences, so it is not there. Okay, so what is subsequence basically? Okay, so let me think and real life scenario. Okay. Okay, let's see. Suppose you all the BS program guys went to the okay. So suppose I have assigned some number to all the BS program guys. I don't know the each and everyone's name, so I will say A1 is the first person, A2 is the second person, A3 is the third person, A4 is the fourth person, and like that. Okay, these are the guys from BS program. Okay, boys and girls all are included. Okay, I am not gender biased. So all the boys and girls are included in this trip, and they went for a marriage. Someone friend sorry, or suppose you will come in my marriage. Okay, you came here for my marriage. So I have assigned some number because there are so many students, so I cannot treat each and everyone, right? Individually. So I have assigned some number from each and every element. So first place I have assigned from this A1 student. Second place I have assigned from this A2 student, third place I have assigned from this A3 student and kind of thing. Okay. And I told them just make a line according to this number. So you guys have made a line. You are a nice student. So you have made, made a line according to that. And suppose here some buffet is running. Okay. Buffet is like there are some sweets and all. Sweets kind of thing. So what is the rule? When this person, these guys can go like this only. Okay. Firstly, first person will go and take, then second person will go and take, then third person will go and take, and then fourth person will go and take. Okay. Now, according to this, I have decided some rooms. Okay. And here also in this room also I have assigned some place. Suppose first place, second place, third place, fourth place, like this. And similarly here. Now, what I am saying, in this place, only those person will go who will take, can someone suggest me some sweets name? I am not
Rasmalai.
remembering right now. Rasmalai. Okay. If someone will take Rasmalai, then they will go here. Okay. Suppose A1 person, now, since here they will go in the arrangement order, or rest who are not taking Rasmalai, they will sit here. Okay. I am not like the rule is I am not caring about those person who are not taking Rasmalai, because Rasmalai is mandatory for all. But since everyone is not, okay, Kaju Katli. Okay, so since everyone is not nice students, so some of the students, they are very Satan kind of thing, and they are like, sir, no, why I will I will agree with you. I don't want to eat rasmalai because I have some allergy kind of thing. So that's their opinion only. So what is the thing is there? Here, firstly, A1 can go, A2 can go, A3 can go, and A4 can go. So now A1 go to there and he took rasmalai. So A1 will go, since he took rasmalai, then he will go to this room and then he will sit in the first place. So A1 will sit here. Now, A2 was like, sir, I don't want rasmalai, I will eat kaju katli. So he didn't took this rasmalai, he took kaju katli. And since he did not took rasmalai, so he just sit here. But this is also first, second, third, whatever thing is there. Now, third person is also like, sir, I don't want rasmalai. So he just, he cannot go this side, so he just sit here. Now, again, fourth person, see, I am not worried about it, okay? Whoever not taking rasmalai, I am not worried about it. I am just worried about those person who are taking rasmalai, because I have, okay, not to say I have, I have mixed some alcohol into it. So I have to take care of them. Okay, so fourth person was like, he is very kind student. So he was like, sir, I will take rasmalai. And then since this two person has not said, because they will not allow to in this room, this A4 will take. So A4 was sit here. According to that, A7 has chosen to take a rasmalai. So this is also a kind of subsequences, right? So that kind of arrangement, because firstly, first person will go, so he can, it's up to him, like it's up to our choice, like whatever thing we have to choose. I hope this session is recorded, but I don't see any link. Yeah, I think link is not there in the calendar. Okay. That is why the strength is low, I guess, right? I don't know what is the reason, but whatever it is. So you are getting my point, what I am trying to say.
Yes, sir.
Got the idea from here. So basically, why this kind of thing is happening? Because I have allowed only one by, they can go by one. Okay, they cannot, this A3 cannot go before this A1 and A2. Okay, so I have defined some qualifying criteria. If someone will satisfy the qualifying criteria, then they will go to this room. And they will zoom like hole, whatever it is, because they eat alcohol from the rasmalai. They got alcohol from the rasmalai and they were like, sir, maja aa gaya. Okay, so understood the idea of subsequences. I hope it will be clear for everyone. Here also,
Yes, sir.
as you can observe, firstly, if I am taking this first, If here I am taking this 4, I cannot, here I am not jumping to this 2 and 3, right? I am not allowed to go because 2 and 3 because they have already decided that we will not eat rasmalai. Okay, understood the idea?
Yeah. Yes.
Okay. Okay, smoking and drinking are injurious to health. Warning. Okay,
Disclaimer.
only increasing order we can take. Okay, we cannot go backward. Like this example, if you are thinking like we are not remembering this kind of thing, just remember this kind of example. Okay, you will let you know what are the things there. So understood the concept of subsequences and all.
Yes, sir.
Okay, let's take some example. So you will help me because you have done the practice assignment. So please help me where some example from the practice assignment. Please suggest some.
Yes, sir. Take sequence as a n square. And
Just a minute, just a minute. Let me know the location of this. Just a minute, okay. Week 7. Location of the question number. Week 7. Okay. Limits and sequence. Activity question. It's a activity question, right? Hello. Am I not audible?
yes, sir. Audible.
Activity question what?
Sir, I am just taking example from the book.
Okay, you have taken some example from the book. Okay. Okay, just take a screenshot and then paste here. Then only I can see now because this whatever you have paste here as a copy pasting method by copy pasting method, I am not able to see. Now it is visible.
Yes,
Are you
sir.
able to see this third example?
Yes, sir.
Oh, what is it saying?
Sequence.
Consider a sequence 1, 2, 3, 4, 5, and that is an is equals to n. Means that the nth place element is nothing but it's a n itself. Which of the following are subsequences of an? So we have to decide. Okay, what about the first one? You will only tell. No.
Yes, sir. No.
Okay, so okay, who are saying this is a sequence? Please say yes or y in the chat box. If someone is saying this is no, please write n. Let's see how many people. Okay, what is the reason?
The second element of the
Because
subsequence
yeah,
is
Position is
beyond
not
2.
same.
Okay, one by one, one by one.
So second element of the subsequence should be the after the second, that is after
After
2.
the second place. Okay, this is one example. Okay, another one is okay. This is the reason why this is not a sequence because here for first place I have chosen, yeah, this first place element is coming from second place. Okay, second place of this first. It can be repeat. Okay, can be repeat. It can be repeat. It depends on the function. Suppose I will give you the example like this. This is my original sequence 2, 2, 2, 2, 2. Now, no matter what are the sequence you will take, you will decide this 2, 2, 2, 2 only. So here I am not seeing the value. I am just seeing their places from where these numbers are coming. Which places, from which places this number are coming. Okay, I am interested about the places of the subsequences. Okay, I am not interested about the value. What the idea? Now, since here I have seen, yeah, this number is coming from second place. So what are the number will sit here? That number will come more than second place, right? Either it will come from third, fourth, fifth, sixth, whatever it is, but it cannot be come from first and second place. But here, what I have seen here, I am seeing here that this second is also a second element, right? Second place element. So this cannot be a function. This cannot become a subsequence. So this is not a subsequence. Okay. What about the second one?
Yes,
Okay.
sir, it is a subsequence
It's a subsequence. Okay. Why it's a subsequence?
because our original sequence is a sequence of natural numbers, and here we are taking the even numbers only.
Exactly. It's up to, because this kind of sequence is following the rules for subsequence of the original sequence that we have given in the question. Okay. Now, what about the third one?
No, sir.
Not a subsequences, right? Not a subsequence. Okay.
Yes.
What about the fourth one?
It is also
It's
subsequence.
also not a subsequence. Okay, understood the idea behind subsequences and all.
So
Okay, what
fourth-
about the
Fourth
question
one
number
is
four?
subsequence, no sir? Fourth one
Yeah,
is
It's a
fourth one
subsequence.
is a
yeah, it's a
subsequence.
subsequence. It's a subsequence. 3, 5, 7, 9, 11. Okay, it's a subsequence, right?
So,
Okay, understood the. Yes.
So, like you just explained that the example, with the example that how we have constructed subsequence.
Which
So
example?
it does not matter whether the subsequences are like that rasmalai and some other sweets one that you're
Yeah, yeah.
using. So
Okay.
in that case, it does not matter whether a subsequence is following certain means exactly some identifiable pattern or not. It just have to be present in the sequence, the
Yeah,
original
it just have to be follows that two rules, like that they cannot be repeat, like they cannot go back, and we cannot add extra elements from some other thing. If something is satisfying these two rules, they will become a subsequence. It doesn't matter whether you are rectifying the pattern into it or not. Okay.
Okay, sir.
It like there will be some certain rule I am not able to rectify. I am not able to verify what is the rule, and I am also not interested on it.
Okay.
Okay. You have to just follow the function.
Yes.
Just like this. It just like a function now. In function, you have seen that yeah. If I am defining some function, I can define by element, right? 1, 2,
Yes, sir.
3, 4, and here also suppose A, B, C, D. So I am saying this person is going to B, this person is going to A, C, 4. So this is a function. I am not interested what kind of function it is. I am not able to write some rules from it like this fx is equals to x square kind of thing. I am not able to write here, right? But this is a function, but
Yes.
I am not able to rectify it. Okay, there are so many functions which are not recognized yet. Okay, but they are
Yes.
still a function because they are satisfying the rules. Similar thing is here. Whether I am able to rectify the rules behind it or not, no matter if they are satisfying these two rules, yeah, that will become a say subsequence.
Yes, I
Got
got
it?
it.
Okay,
Yes.
this is a basic thing. Like they will ask some example into it. What kind of example they will ask? They will say they will ask about limit of if the limit of a sequence will exist, then let us know the limit of that subsequence will exist or not. That kind of example they will ask. Okay, for that, if you want to discard thing, you have to take some subsequence example, like arbitrary example kind of. Okay, you cannot for that you cannot say, sir, I am defining a subsequence like this f of n bn is equals to 2n plus 1 kind of thing. So that kind of thing, no, it's not necessary basically. that is satisfying the rule. What are the rules we have decided? We have made, so that will become a subsequence. Okay.
So this also does imply that where our main sequence is converging to, the same is our any subsequences also converged to that point.
Exactly.
Yeah. Thank you, sir.
Let's move further. What about question number 4? Okay. What about option 1? It's a subsequence or not? What, please?
Yes.
It's a
Yes, sir.
subsequence.
Yes.
It's a subsequence, right? What about the second
Yeah.
one?
It is also
Yes, sir.
Yeah, what about third one?
no.
Okay, forget about it. What about the last one?
No. It is
It's
not a
not a
subsequence.
subsequence. Okay. Why it's not a subsequence?
Like if I put n equals to 1, then it becomes 1.5 square, and 1.5 is not an integer. That is, it's not a valid index.
Yeah, because what are the
we
number here? Here is coming. They are not coming from natural number. Okay. So what are the sequence that we are seeing here?
oh, sorry.
So here also that we are saying that Bn is equals to 2n plus 1. Bn is equals to 2n. This Bn is defining a places of the sequences, right? If you will put n is equals to 1, so this will give you a b1 place. B1 place means b1 first place of the subsequence part. First place of the let's see. I just want to explain this kind of thing. Suppose I have the sequence like this. Okay, n square I will take. So 1 square is 1, 2 square is 4, then 9, then what? 16, then 25, then 36, 49, 64, 81, 100, and that kind of thing. This is an n square sequence. Okay, an is equals to n square. Now I am saying take this bn is equals to 2n plus 1. What does it mean? This is a sequence kind of thing. Okay, so I am saying not bn is equals to this br is my sequence. Br is my sequence, and where r is what? R is 2n plus 1. Okay, br is sequence like this. P1, P2, like this. Here bn should be there like this. Okay, and here this r, okay, just take it as r. R is what? 2n plus 1. Okay, so for n plus 1th place, for r is equals to 1, because I need to find this b1, b2, and br kind of thing. Okay, so for r is equals to 1, what is the value of n? I cannot find the value of n, right? Okay.
Minus 1, but that doesn't belongs to domain.
And it has to be 0 at that time. Then only it will
Okay,
be.
it doesn't matter. Just put n is equals to 1 here. What it will be?
3.
It will be 3.
3. So my first element, what are the coming from here? That element should belongs to the third element of this. Okay,
So,
forget about it.
so,
Forget about it. Forget about it. It's a
so,
confusing.
so should not we look like C that you said that this formula is a function that is mapped from some natural number to some value? Yeah. So
Mhm.
if you are saying that Bn is 2n plus 1 means for
Not
a
bn is
value.
equals to. It's not bn is equals to 2n plus 1. What I am trying to say basically, what are the sequence I am taking? So my idea is where this R is something B1, B2, B3, B kind of thing. So there is a increasing function. Okay, this R is nothing but this is a increasing function of this N.
Okay, got it.
Okay, this R is defining like a function, some function like N square, whatever it is. So this N is what? This N. I'm talking about this N. Okay. So this N is what? This is the places, right? This is defining my places. 1, 2, 3, 4, 5 kind of thing. Here this R is also defining places, but what kind of places it is? It's the place of our new subsequence. So if I will define some increasing sequence into it, increasing function into it, I will say R is equals to N square. N square what? What it will be? If I want to ask first place, I will put N is equals to 1 here. If I want first place of this sequence, I will put N is equals to 1 here. So I will get here what? N square is what? For N is equals to 1, it will be 1. So here P1 should be 1 only. Okay. If I need second place of this this number. Okay. So here I am not putting N square. Let us say because N square both are same. So I will say
N plus 1.
N plus 1
N plus 3, suppose N plus 3 or N plus 5, whatever it is. So if I want to write first place of this number, this sequence, so what I will go, I will say just put N is equals to 1 here. So for N is equals to 1, I will get my B1.
Yeah.
So what will be my B1? For N is
6.
equals to 1, it will be R is equals to 6. So I need 6th place of this sequence. Right? I
So
need
the
6th place of the sequence. So
Sir,
So
not
number
the
of
element, sir. Not the number. Only
not
position.
number. I need, yeah, I need 6th position number of this sequence. So what is the 6th position? This 36.
So
So
like
what will
so like you're saying we have to put Bn or like a 6th position, but we calculated like N plus 5. That is like calculating to some
okay,
natural number
basically
itself.
I think I am committing some mistake into it. It should be like this. Okay. Aha. So what is the idea? This R should be, if this kind of thing is happening here. So what kind of thing I am saying? I am saying if I need first place of this number. First place of this number. So I need to calculate, I need to put N is equals to 1 here.
Okay, in that
Okay,
so
not like that, not like that. Okay, just
would not it be better to write it like as we have
N
mentioned
is equals to R plus.
yeah,
Okay,
and then
now it's correct.
and putting this N as N square, then that we will be like going to
Yes. Okay, so there is a relation between this R. Okay, this is my subsequent. Okay, let me write it on more precise way so that it will be clear for everyone. Okay, this AN is my original sequence. This AN is my N square, which is my original sequence. I am defining another BN. Okay, another BN. Not BN, BR. In this BR, what we will have B1, B2, BR kind of thing. Okay. And the relation between this R and N is what? Here N is equals to suppose 2R plus 3, whatever it is. Okay. Now, I need to calculate this B1, this B2, this BR kind of thing, right? Now, since
Yes, sir.
I need first place, it means I need for R is equals to 1. Which number will become my, which place number will become my B1? So what it will be? Just
Fifth
put R
number.
is equals to 1 here. What I will get? N is equals to 5. It means that B1 will become my 5th place element of this, or I will say here A5. Right?
Yes, sir.
If B1 will become my A5, so what it will be? 25. Now, for second place, I need R is equals to 2. For R is equals to 2, N is equals to what? 2 to the 4 plus 3 it's 7. So B2 will become what? A7, which is 49. So what is it? Basically, the relation between the relation is what? Increasing relation that I have explained earlier, right? I cannot go back. You are relating both the point here. Whatever relation I am defining here, this is a increasing relation, right?
Yes, sir.
Right. So that kind of thing is happening here. So we can define a function like this as well. What
Got it, sir.
I can define a sequence like this. Okay. Let's move further. What is the next topic? Okay, understood. You got the idea behind the sequence and subsequences thing.
Yes, sir.
Okay. If you have some doubts on the practice assignment regarding to this sequence kind of thing, practice or graded kind, not graded activity question. So please, you can ask. I will give you 2 minutes for asking the question. Or if you are not going to ask, I will move further for limits. Okay. If you have any doubts into it, you can feel free to ask. Okay.
Yes, sir.
No doubts? I'm again saying, if you have some doubts into it, please ask. Okay, let's move to forward. Limits of a function. Okay. So what you guys know about this limit of a function?
So for now,
Please
I
let me
understand.
know.
For now, from the limit, I understood that for a large input, what does my function like goes to? For a consist, if I like consecutively increases my input value, so where
Wait.
is my function going to going?
Okay, limits of a sequence is different thing. Limits of a function is a different thing. Okay. So
Okay,
what
sir.
you want me to explain? Limit of a sequence or limit of a function?
Limit of a function.
Limit of a function, right? Limit of a sequence is easy. In the limit of a function, limit of a sequence, we just need to see for large, like if I will increase the value of n, okay, if I will increase continuously increasing the value of n, so according to that, I have to see what are the sequential value, where the sequential value is going. If that sequential value is going closer and closer to some number, then that number will become my limit of a sequence. Okay. It's not
Yes.
necessary that for every sequence that kind of thing happen. If for a given sequence this kind of thing is happening, then we will say that sequence is converging to that number. Okay.
Yes.
I hope you got a brief idea about it.
Yes,
Yes,
sir.
sir.
Actually, I got like I said that because means we can treat sequence as a function also.
Yeah.
So because of that, my like it get like mixed up at that, but now it's clear. Yeah.
Now it's clear.
Yes, sir.
So should I have to explain this limit of a function? If you have clear this definition, we will move forward for the example. We will take some example from the activity question and we will solve. We will not going to waste our time in the definition because it's trivial, not. Please tell me if anyone have some doubt into it. Please let me know now. Otherwise, I will move forward for the activity questions or practice assignment, and then we will say what kind of question they can ask.
Yes, sir. Please move forward to activity questions.
Okay. Okay, so we have some pre-decided rules for limits, right? If you have books and you have some okay, if you have some rules in your book, please paste here so that I will use that rule. Not rule, like some formulas are there, some predefined limits are also there, right? Okay, what about the seventh one? What will be the correct one, correct answer? And how will you approach that kind of thing?
So for the seventh question, how I proceed is plug in some n values, consecutive like n1, 2, 3, and then see that what's happening with my en, the output value.
Okay, let's see. So you have a sequence Sn. What is your Sn? Under root something. Here is the minus
Is it 2n plus 1 minus 2n?
2n plus 1 minus 2n. Okay. I need to see whether this sequence is convergent or not. If I need to see this sequence is convergent or not, what I have to see whether the limit is exist or not. Right? Limit of a sequence is exist or not. So how many ways I have? See, there are so many ways to check whether the sequence is convergent or not. But what are the ways you guys know? How many ways you know for checking this sequence has limit or not?
Sir, we approach from left and right,
This
and
is not
we
a
check
sequence
if.
of this is a limit of a sequence. This is a sequence,
Oh, sorry.
not a function.
So we just put the values like
This is
consecutive
one
1 or
this
1
this
2.
is one way.
Yeah.
Putting the values of n. What about another one? Is there anything else to check? No matter you guys you are wrong or not, but if you know something, then please let me know. Whatever it is. Don't think that like that sir, it will be incorrect and everyone will laugh. Okay, don't think like that, because this is not a offline class.
So for the sequence, the thing is, beside putting some value and reconstructing the sequence, uh,
Hmm.
I don't have anything else in the mind. The simplest would have been like putting directly there's a large value for n and then c, but like this case, it becoming like infinity minus infinity, so that's not making some sense. So I will go for
Yes.
with the reconstruction of this series and then see where it's going.
Okay, not series. Okay, this is a sequence.
Yeah, sorry,
Series
six.
is different. Okay, so someone is saying, sir, putting large value of this n and then see where this sequence is going. So my question is, does this is an appropriate way to check this kind of thing? Because it will take you lots and lots of your time. Suppose if you want to put n is equals to 1000 or n is equals to 1 lakh kind of thing, because you are saying, sir, this just see where for n goes to infinity, where the function the sequential value is going. That kind of thing you need to check. So if I will put that kind of big value, so whether I am able to recognize that kind of thing, what will be my functional value?
Yes, sir.
Sometimes you are not able to calculate the functional value, the sequential value, right? For for small n, suppose you want to calculate n is equals to 1. For n is equal to 1, okay, let's take. What will be my Sn? So for n is equals to 1, it will be 3 minus root. For n is equals to 2, it will be 5 minus 4. Then it will be 7 minus 6. That kind of thing is happening here. Okay. Now, if I want to calculate, I want to check what will be my limit. Thus, I can check directly from here. Because I don't know what is the value of root 7. I don't know the value of root 6. Right?
Yeah.
So what is the idea after that? So see, the thing is, whenever you got your sequence, suppose this is my sequence. Firstly, observe that sequence. What kind of sequence it is? So here, as you can see, here some under roots are there, and you can see it's a 2n plus 1 number. It's a 2n number. So what is the difference? It is just 1. If I will add 1 here, so it's just a number like, so here also, as you can see, 4 and 5. Just difference of these two numbers is just 1, right?
Yes.
Right. Now, if I will calculate the roots of this 4, it will be 2. And what about this roots of this 5? It will be somehow 2.1, something like that. Similarly, since I don't know what is the value of root 6, so I will calculate the another thing, root 9 and minus root 8. So if I will calculate root 9, it will be 3 minus what it will be? It will be 2.9 something, right?
Yes.
Right. So whenever I will take large and large, okay. So what about this difference? This difference will be like 0.1 something, right? Then this difference is also 0.1 like that. And whenever I will move forward, this difference will be like 0.00 kind of thing. Then if I will take large and large, so what is this difference? This difference will go towards 0, right?
Yes, sir.
By observation, what I can see that because if I will take large and large n, the difference of this root under root 2n plus 1 and minus 2n under root this 2n, it will be the small and small, it will go towards 0, right? Because this number will become equal to each other, right? They will try to match each other, right? Right? Hello? Am I
Like,
audible?
sir,
Yes, sir.
sir, like what I did for this question was I just
Mhm.
plugged in like for the first three sequences for this like root 3 minus root 2, then it is root 5 minus root 4 and root 7 minus root 6. What I did is I just directly calculated the values, exact values. And I see like it was like point something, then it was decreasing. So I came to a conclusion directly that yeah, it's going towards 0. But if I say like saying like in this abstract way that it's a that is something root and difference of some roots with a difference of 1, like that's I'm not getting like how it's like we are seeing that it's converging exactly.
Okay, what is the thing is what the thing is here? The thing is that here what I am saying, I am taking under root. Okay, I am taking under root. So whenever I am going large and large value of n, this under root n, the difference between this under root 2n plus 1 and this under root 2n, it will be small and small. Okay, why it will be small and small? Because it's just the difference of one number only, and you are taking the under root of that number.
Okay.
Okay, why? Why? Because the square root, how the perfect square will go? 1, 4, 9, then 16, then 25, then 36. As you can see the difference. The difference here, what is the difference? 3. Here, what is the difference? 5. Here, what is the difference? 7. 7, right? Yeah. Here, what is the difference? 9. So this difference is continuously increasing, right?
Yes, sir.
The difference is continuously increasing. It means that if I will take any number from 9 and 6, any number from 9 and 16, its square root will come from 3 and 4, right?
Yeah. Yeah.
9 is, if I will put any number, see here I am just taking natural number. So if I can take any number from 9 and 6, the square root will be come from 3 and 4 only, between 3 and 4 only.
Yes, sir.
Okay. Now, now here, how many numbers are there? Natural number 7, right? So if I will take that 7 number, so I can I can distribute this into 7 parts, right? This interval, the length is 1 only.
Yes, sir.
7 part. Okay. Let's take a 10th place and 11th place. Now, what are the number? 121 and 100. If I will difference this, I will get 11. So I need to take 11 parts of this interval, right? I can get 11 more points into it in between these 2 points. If I will square root of all those points, it means that if I will square root of 101, if I will square root of 102 and kind of thing. So that all the 20 or 21 points I will get in between this 10 and 11 only, right?
Yes, sir.
Okay, so what is the observation? The observation is that whenever I am increasing the number, see, since the distance between of this interval is 1 unit only. So whenever
Yes.
I am increasing in the numbers, that partition or whatever you will say, the part of this, the number of square roots in that difference will be increasing. Like I am getting more and more partition in of this interval, right?
Yes, sir. It's same as
I
saying
am,
like what was 1/7 for between 3 and 4 become 1/11th distance. Means 1/11th of a unit distance between 10 and 11.
yes,
So that's decreasing. Yeah, got it.
that's it, decreasing, right? So whenever I will take large and large number, this partition, the number of part, whatever I am doing, the number of division will be increased, right? So this difference will be decreased.
Yes, sir.
That's what I'm trying to say here. I am just taking large and large number, and if I am trying to see the number, the difference of square roots of those two number, it is going to decrease, right?
Yes,
So
sir.
this is what? This is square root of 100, and this is what? This is square root of 101, right?
Yeah.
Right. So this distance is decreasing whenever I am taking large and large value of n. Here this difference is 1/11.
Yes, sir.
Got the idea? This is
Yes.
one way. This is one way. Just observe the sequence, what it is saying, and then behave according to do the thing according to that. Okay. Okay. What is there any other way that are coming into your mind?
Yes, sir. Just rationalize the thing.
Yes. One more thing. Rationalization. Okay. So suppose you have a SN here. Math people will be aware about it. N plus 1 minus 2n. So what is rationalization? I just want to make this thing as rational number. So for
Rational, yeah.
Divide and
irrational number,
multiply with.
this is an irrational number. So I just want to make it as rational number. So for making the rational number, I will divide root 2n plus 1 plus root 2n plus divided by. I can do this thing, right? Why? Because this will be cancel out and I will get whatever I want.
Yeah.
I will get the initial thing as well, right? I can write it as like this.
Yes, sir.
Okay.
Yes.
Why I am doing? Because I know this formula. Here I am, if you are able to say here, square root kind of thing is there. So I know this formula, a square minus b square is equals to a minus b and a plus b. Here I have this is my a, this is my b. So here I have minus thing. And since here square root here square root is, since square root is here, so if I will manage to make it a square, then I am done. So for making it a square, I know this formula. So I just want to multiply by a plus b. So for multiplying this a plus b, I need to divide it as well. So I am just dividing it. So what it will be? It will be 2n plus 1 whole square. So what it will be? 2n plus 1 minus 2n whole square. It is 2n divided by 2n plus 1 plus 2n. Got it? So now, as n will go to infinity, this whole term will go to infinity, and since it's a reciprocal, so this whole term will be go to 0. Here also you will get. So this is also another way of solving this kind of thing. Right? So what is the observation here? Putting the values, it's not an appropriate way. So firstly, whenever you got a sequence, just see and observe what kind of thing I can do. Okay.
Yes, sir.
Okay. Let's take some
Yes.
more example. Okay. So what is the correct answer? An is convergent, right? And limit of an is 0. The first two options are correct. Okay. What about the eighth one? An is equals to n raised to the power 1 by n.
Yeah, it is given it has a limit 1. Then we have to check the options.
So it's ln of 1. ln of 1 is 0. So it's 0. Yeah.
Sorry.
Its limit is given of en is equal to n raised to power 1 by n. Limit is 1. So we can like substitute directly that limit inside the natural log function. So that's saying that ln of 1 is what?
We cannot
That's 0.
directly put. Okay. So did you learn the continuous kind of thing? So
Continuity, yeah.
in this week 7.
Yes, sir. So
So in
there is
7
a
we did, but
property
log, we
for
know that
An is equals to 1 by. Sorry. Yes, someone was saying something.
so log n is a continuous function, no?
If you are not
log,
aware about it, what is continuous function, how will you say it's a continuous function? Firstly, you need to know the definition, right? Definition of continuous function. Because most of the person are not aware what is continuous function. Okay, forget about it. So this is your function, and the thing is that they have given that limit of an is 1. Okay, what's the issue? How will I get the limit of this an is 1? Can someone please let me know how we can say? How will I calculate the limit an is 1? Because they can give you the example like that only also. Okay. For
just by
calculating this.
taking the log.
Yes. Just take log both sides. I can take like that, right? ln of an. So what it will be? ln
1 by
of
n ln.
n raised to the power 1 by n, which will be ln by ln of n by n. Right? I can take. I am just simplifying this kind of thing. Okay. So it is what? Limit n goes to infinity. Ln n divided by n. I need to calculate this. This is similar kind of thing. Limit x goes to infinity. Ln x by x. Right?
Yeah.
How will I calculate? How will I move forward further?
Sir, we can use the L'Hopital's rule.
L hospital.
Yeah.
We cannot use that because we don't know about it. Did you
so
heard about the
one idea
expansion
came.
of log series expansion of log x, that kind of thing? I think it is not there in your syllabus. So we
So
cannot
we
use
have
that.
So, but one thing we know about log is log
Yes.
is does not grow rapidly after as n increases.
Yeah,
Beyond
that we
certain.
can do. That we can say.
So if after a certain limit, log is like slow, too much slow.
Yeah, the
And
slope of the log is low. Just see the slope of this function. This is my x, y is equals to x function. And my log x will go like this. So if I want to see the slope of ln x, what is the slope of ln x? It's 1 by x, right? For
Yes.
each point. You will let you know further. Okay. For instant, you will say, for now, you just think that it's a 1 by x. And what is the slope of x? Slope of x is 1 for each point. For all x, it's 1. So just see here, why it's 1? Since it's a y is equals to mx plus c kind of thing, where m is equals to 1 and c is equals to 0. So you will get y is equals to x. So this m will become your slope. So the slope of the denominator thing is 1. Okay, so whenever x goes to infinity, this slope is going towards 0, right?
yes, sir.
Right? What I am saying, I am saying if you just see the slope of ln x. The slope of ln x is nothing but 1 by x. Okay. And the slope of x is what? 1. Right?
Yes.
Right. So as x goes to forward, as x goes to infinity, the slope of this function ln x goes towards 0, right?
Yes, sir.
And this is still constant. The
Yes.
slope of the function x is still constant. So what is the observation here? Observation is that after certain points, this ln x, the slope of the ln x is decreasing. It means that the slope, like slope is what? How rapid this function is increasing, decreasing, and how fluctuating the fluctuation of the function. So it is kind of, this function will be behave like a flat function, right? After some time, because the slope is going towards 0. Towards 0, it means what? Slope is what? If I will take this point, so I need to draw a line like this, then this angle. So towards 0, it means that this is just going, this line is going to going parallel, is trying to be parallel of this x-axis, right?
Yes.
Yes.
Okay. So if I want to, if this line wants to parallel of this x-axis, so the graph has to be flat like that, right? So it's showing that, yeah, it's showing that the increasingness of this function is very less, or the fluctuation is very less, right?
Yes, sir.
Right? As
Yeah.
compared to the y is equals to x function. Okay, the thing, what does it mean? It means that if I will put x is equals to something, whatever it is, so this function will get more and more value, but according to this function will get less value. It's
Yes.
just like this is my have you heard about this rabbit and turtle story?
Yes, sir.
Yes, sir.
Okay, so this is my turtle. The speed of this function is my turtle. This is my rabbit. So if I will I will fire the gun and I will say run. So this function will finish the race before this function, right?
Yes, sir. X will go ahead. Denominator will be
Yeah.
fast.
After some time, it will go fast,
Yes.
right?
Yes.
So it has some edge because of its speed. Or I will say, if I will do race on tractor and Formula 1 car. So who will win the race? Obviously Formula 1 car, right? And if you are not aware about Formula 1 car, so we will say, if I will make race on Bolero, and everyone know about Bolero, right? Or Splendor Plus and tractor. So who will win the race? Obviously Splendor Plus, right?
Yes.
Right? So the thing is, the denominator part is your Splendor Plus and the numerator part is your tractor. Okay, so this will go to infinity before this function. It means that this function will be behaving like it will be walk slowly, and this will going very fast. It means that this whole function will go towards zero, right? Because this is going very fast. The denominator thing is going very fast towards infinity,
Yes.
right? So it means that this whole function will go towards zero. Though the speed is very low, but it will go towards zero, right? Because this will, this will dominate this ln x function after certain point.
Yeah.
Right? Or if you have seen that Captain America Civil War, first I think Winter Soldier movie. So here Captain and what Sam Wilson, right? So they were running, and then Sam was just running slowly, and Captain was finishing all the whatever all the rounds of the ground, right, in a very fast way. So that kind of thing is happening here. So after certain point, this ln x, like this x function will dominate this ln x. So whole thing will go towards zero. So what did I get? I got that ln of an is going towards zero. Okay, since ln of an is going towards zero, if I will take anti-log, or if I will put e raised to the power ln x, so I will say why I can do like that, or why I can say like that, because there is no such breaking into this function, right? There is no such breaking in this function as well. There is no such breaking point kind of thing, right? I can make this function before like lifting my pen, right? This is a smooth function, right?
Yes, sir.
It's a smooth graph. Once I start making of this graph, I can draw this graph before lifting my pen. So there is no break kind of thing. Break, what does it mean? It means that there is no such break kind of thing, that kind of break. There is no jump kind of thing. Right?
Yeah.
Yes, sir.
So I can go like this. So I can do this. So this will become an, where an goes to 1. Got that idea? After some time, when you will read the continuity concept, then you will then you will able to understand why we can directly put why I can directly jump here to here, because this e raised to the power x function is continuous at 0, and ln x is also continuous at like it's a continuous function. It's also a continuous function, so we can directly go like that.
So could you also explain like two identities that was included in the lecture, that is limit of x tends to 0 of sin x by x in some similar fashion, and of ln of 1 plus x divided by x as x tends to 0. 1 plus
ln
x
of 1.
divided
This
by
is also, this is both thing, all this going to 0, this going to 1.
also both goes to 1.
Both thing goes to 1, right?
Yeah.
Okay.
Yeah, like now I'm thinking of constructing what we did with this log ln x by x. Now I am trying to think in the similar fashion.
I
Uh,
don't think so. This ln 1 plus x by x will go towards 1. It will go towards 0.
so it's given in
Cannot
the
go
lecture
towards
as x tends
No,
to
sir.
0.
As we expand the one ln 1 plus x, we get the first term as x. Then we start with negative x square by 2 and all.
here.
Then we
Where you are going towards x is equals to
0.
x goes. Okay, you are going x is equals to 2. I was
So
thinking like you are
for
going
both
towards
function
x.
x tends to 0.
Yeah. Yeah, it's correct then. If you are going towards 0, then it's good. This good. Okay, so what the issue here? Okay, let me finish the first question, then we will go towards it.
Okay, so
Where is the question? Okay, now you can see this thing we have already calculated. Right?
Hmm. Yes, sir.
What about this ln 1 plus n raised to the power 1 by n? So just see here ln is I can make a graph without lifting my pen. Everyone is aware about the graph of ln function. That is why I am using here graph of ln function. So here as n goes to infinity, this thing will go towards 1. So this whole thing will go towards 1 plus 1, which is ln 2. Right? So you can easily calculate this kind of thing. I hope.
Yes, sir, we can.
You can calculate it. And okay, so let's talk about this kind of thing. I have this function fx is equals to sin x by x. So claim is that as x goes towards 0, this whole fx will go towards 1. Why it is? How will I see? There are two ways to see. First is my intuition, just checking the graph. Another one is just there are so many ways, not exactly two ways. Just apply the definition of the sequence. Oh, sorry, the definition of the limit, what it is saying, or many ideas are there. So what? Let's take by intuition, because that is necessary for you. Other thing, I don't think so. Currently, it's necessary. But yeah, this thing is necessary. So this is my sin x graph. So this is my y. Okay, can I show you in GeoGebra? It will be more better.
Yes, sir, a little better.
Just a minute. It takes some time. Everyone is able to see the screen. GeoGebra.
Yes, sir.
So this is x graph. Then we have sin x graph. Okay. Then we will talk about sin x divided by x. Okay. So let's know this. Just see this graph. Just see the graph. Here, as you can see, this red one is what? This is belongs to my sin x graph. This green is my x graph. So as you can see, whenever I am approaching towards 0, no matter from which side I am approaching towards 0, this both function is trying to overlap to each other, right?
Yes, sir.
Right. If I will remove this is my y is equals to x function, and this is my sin x function. Okay, so if I will try to see both function as x goes towards 0. So whether no matter whether I am approaching from this side or this side, I can see this both function is trying to overlap to each other, right? Just see, if you will
Yes,
see
sir.
by this way, here there is some basic difference. Here there is some basic difference, but the difference of these two function is collapsing. Like these two function is collapsing to each other whenever I am approaching towards 0, right?
Yes, sir. There is a complete overlap.
There is a complete overlap, not exactly complete overlap. The complete overlap only this point. There is some difference, but that difference is too less. It's negligible kind of. Okay, so it means that it's just like you are doing x plus 1 divided by x, and you are saying x goes to infinity. That kind of thing is happening here. or you are saying x goes towards 0, not 0, infinity is. What does it mean? So what does it mean? It means that sine x is somehow behaving like x whenever you will go towards 0, right? They are overlapping to each other,
Yes.
right? So in sine x divided by x, I can write it as like x
X
by
yes.
x when x goes towards 0, right?
Yes.
Because they are overlapping to each other. I can write it as like this.
Yeah.
So it will become what?
At this
1.
particular point, yeah.
Now you just see the sine x graph. Oh, it's not showing. Okay, it is showing. I have to zoom out. I'm not able to zoom out. Okay, let's see this graph. Are you able to see graph?
So graph
No.
paper is visible, but graph is not visible.
Okay. Just see this graph. This is your sine x by x graph. So this is your 0. This is your 0. This is your 0. So whenever this graph whenever your graph is approaching towards 0, here your graph is going towards 1, both by both sides. This is your 0, right? Corresponding value, if you see, this is going towards 1. Understood?
Yes, sir.
Similar thing is happening for log 1 by 1 plus x and x. Similar thing is there. Okay? Okay.
Yeah.
Yeah. Oh, yes, sir.
But sir, it
thinking about it.
it will go to 1.
Yeah, it will tend to 1.
Log 1 plus x by x as x goes to 0.
Yeah.
So it's given in the
Mhm.
lecture that it should tend to 1 as x tends
Yeah,
to
it
0.
should tend to 1. Yeah, sorry. For infinity, it will go towards 0. For 0, it will go towards 1. So got the idea? Similar thing is happening here. Like they are trying to overlap each other.
Got it, sir. But like now, one thing here, when we are seeing the picture of this overlap, then one thing came to mind, like for a particular point, when two graph intersects at if two graphs intersect at a particular point,
It does
yeah,
not mean that they will overlap to each other.
yeah, it does not mean that.
It does
But
not mean that, because if you will put if you will take a line x plus 1 or x plus 2. Okay, this is a line y is equals to x. This is they will also they will intercept at a point, but they will not overlap to each other. So you cannot say that x plus 1 divided by x plus 2 will go towards 0. Or suppose, for instance, I will take y is equals to 2x and y is equals to x graph.
so I am thinking like, why is this intersection, when these two curves intersect, it seems that they are overlapping. What's make this intersection so special? That's
The
what I'm
special thing
thinking.
is the special thing behind is just see the just see the slope of this two graph.
Yeah,
Slope of this two graph at 0, okay, not at any point, but at 0, both are same. you can say the slope of this function is cos x. How you are getting this slope? Like whenever you will learn differentiability thing, you will able to understand what will be the slope. Okay, cos x, and what is its slope? It's 1. Now, as I need to calculate the slope at 0. So it will be what? Cos 0, which is 1. So the slope is same, right? Since the
Yeah.
slope is
Yeah.
same, means that since both functions are becoming 0 at 0, right? And since they are starting at same speed, if two cars are running, okay, if two cars are running and they are like they okay, two cars are racing and they are racing in the same speed. So it's obvious now the speed path will be overlap to each other.
Mm. Yes. So
So
now,
the starting pace is same.
Mhm. Yes, sir.
What I am trying to say.
Yeah,
Suppose this is
got this point. Yeah, exactly. Like, this is like what makes L hospital rule work. This is what
yeah,
all.
exactly. This is what the idea behind the L hospital rule. This is the L hospital rule, exact basically that we
Mhm,
are applying here. We are trying to seeing the tangent.
mhm, mhm,
So this is the L hospital rule that we are trying to see. The thing is that for why we are studying L hospital rule in week 9 or 8, because in that particular days we will able to understand the concept of differentiability, and for the differentiability with the help of differentiability we will directly calculate the tangent. Here we are not able to calculate the tangent directly, but
mhm,
yeah, there is one nice way. By seeing the tangent of the given function, we will easily see where will be the limit go, where will the limit.
mhm. Yeah,
So this is the idea.
if two graph intersect at a point and they share the common uh tangent, then that means the graph are overlapping at that particular point.
No, if they have same tangent on that point.
Yeah, what I am saying is
Yes,
two
yes,
graph
yes, yes,
intersect plus they share a common tangent at that point. Then
yes,
they
yes, yes,
overlap at that point.
yes. They will overlap, and the limit will be. If you will see the numerator denominator part, the limit will be
The one.
1.
Yeah.
Yeah. Yes, and what's the issue? Sir, I am still can't able to access my discuss section. What is discuss section? On that dashboard. Okay, can you please help me with that dashboard, right? Okay. Okay, what is the issue? Senwas, can you please unmute yourself and then let me know
I can't log in to that.
what it is showing basically.
Wait.
Can you send me a message on my email ID regarding that?
What's your email ID, sir?
This is my email. Just send me message. Okay.
Okay, right.
Just send me on chat box. Don't send me on mail because there are some lots and lots of mail which are coming from the students. So I'm not reading that kind of student. Like the discussion kind of thing is happening on that mail. So I'm
Should I
not seeing
send my
that
email?
discussion part. No. By chat there is a like in the email section there is a section where you can directly chat just like WhatsApp kind of.
Mm,
Okay, there is one section where you can directly chat with anyone via email. Just go and see, you will find it. Okay, just
Okay, you continue.
send me the screenshot as well. Okay.
Okay.
Okay. Yeah. So understood the idea behind it. So how will you check? Basically, what kind of a question they will ask from it for the sequence and this function limit of a function or limit of a sequence. thing, they will just give you a simple sequence. They will give some an is equals to something something. Okay. With the help of the simple sequence, they will just say, they will directly say just find the limit of this an. That's it. Similar for function as well. Either they will give you some step function kind of thing or whatever function it is, but they will give you a function, they will give you a point, and they will say at that point what is the limit of this function. Okay, let me ask you one question. Fx is equals to, I have this function x square and x plus 1. Okay, when x is greater than 0, when x is less than or equal to 0. Does limit of fx at x equals to 0 exist? If yes, then find it. Okay, just let me know the answer of this question.
No, sir.
I will say that it does not exist because if we from a negative side, that is when x is smaller than equal to 0, what we get is like this in just a second. We get is 1, but as x is greater than 0, then we have a different value. That is left and right
Yes,
hand limits are different.
yes. Left and right hand limits are different, so it will not approach. Like the limit should not exist at 0, right? Why? Or you can go by graph. If you can see, your x square graph will go like this, but you need to take the greater than thing. Oh, so I will take this part only. Okay. What about the x plus 1 graph? X is equals to 0, y is equals to 1. So it will be, this graph will look like this, right? No.
So, sir, one question came to my mind now. For this function, like we have defined these functions too in this split manner. So it's like most of the cases that till now I have seen the practice and all. Whenever we are dealing with this type of split functions, like x is greater than this, and x is less than this certain value than this function. In that case, most of the functions that means almost all functions that I have seen are seems like discontinuous.
Yeah, don't use that word, but yeah, it seems like if I want to make this graph, I just have to complete this graph like this. Then I have to put my pen, and then I have to start from here. That kind of thing is happening. But this is not the exact case that you are seeing. Okay. There is a possibility that there are so many functions. If I will define like this, fx is equals to minus x and plus x when x is less than 0, x is greater than or equal to 0. In this case, your
Limit
graph
zero.
of the function will look like this, and this is continuing.
Yes,
This
sir. A
function I can make. Limit
limit
at
also
0
exists.
is 0.
Yes,
It's
sir.
also exists. Okay. This is
Yeah.
not the case. They are making the function like that because they want to what is the idea behind this kind of question? The idea behind is that whether you are aware about left hand limit and right hand limit or not. If you are not aware about left hand limit or right hand limit, you will do incorrect thing in this question, right?
Mhm. Yes, sir.
You are not able to understand. You are not able to solve this kind of question. So that is why they are asking this kind of question, like whether you are aware about it or not. That's it.
Mhm.
Otherwise, we will give you a simple function and we will say find the limit.
Mhm.
Why
Yes.
I want to make this thing complicated? This
Mhm.
kind of idea that we want. Okay.
Sir,
Okay.
one question.
Yes.
Sir, can infinity be a limit of any function? Like if we find the limit of any
No.
function fx.
No. 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 No.
Sir,
Infinity. It means that what? If I am saying some L is a limit of my function at any point,
yeah.
at a, suppose x is equals to a, this L should be coming from R, right? Real number. in the beginning of the definition, we are saying that this L belongs to R is said to be a limit of this function at x is equals to A. If the
Yeah.
sum, if the LHL at A is equals to RHL at A,
RHL at A. Yeah.
what does it mean? It means that this L has to be coming inside this R, huh? That we have already predefined in the definition. Not here, Senwal. You just send me on email. Okay, just do email by now. Okay, so I will just see. Just
Okay.
send me an email by now. I will just, I'll just.
Okay, sir.
Okay, understood the idea?
Yes, sir. So take an example for fx. X square by x plus 1.
X square by
X plus 1. And find
X
the
plus
limit as x approaches to infinity.
X approaches towards infinity. That we need
Yeah.
to find. So it will go towards infinity.
Yeah. So what we say about it, like the limit of fx is
Does not
doesn't
exist.
define. Yeah,
Does
does
not exist. Not defined, does not exist. We know that, yeah, this going towards infinity, since infinity is not a real number, it means that it does not exist. If I will
Okay.
include this infinity as a real number, then I will say it will become infinity. But it is not a real number. It's not a number, basically. It's just a symbol, just a concept. It's just the imagination kind of thing. Okay. So it does not exist. Not defined, not defined, but what does it mean? It means that this is not equal to each other. Right?
Yeah.
Not defined, it means that.
Okay. Does not exist.
It does not exist. Okay. Because whatever thing we are getting, we are not aware about. What the idea? It's just like if you want, if I will tell you, just calculate the roots of this equation. Okay, the real roots. They does not exist, right? It does not mean that
Yeah.
the roots does not exist. The roots will be I plus minus I, but they are complex number.
Yeah.
So we will say the root does not exist.
Yeah. Oh.
Okay.
Sir, what about 1 by x
1 by x
as
at what?
x approaches to infinity?
X approaches towards infinity. It means that this person is constant. See the pace now. This person is constant, and this person is continuously going towards infinity. This person is saying, I will become large and large. So this whole thing will go towards zero only. No? It's just like
Yeah.
this person is a very bhula person, and this is very satan kind of person. This person is continuously beating this. So at one point, this person will die, and this person has to go jail. Means that the resultant thing will become zero.
Yeah. So limit will exist and limit will be 0 for 1 by x.
Yes.
So, please help me in
Sir, but
differentiating a point like
oh,
here. That is,
Sorry.
we are treating a sequence as a function, yeah. But when we are talking about limit of a function, we are talking about whether the right hand limit or left hand limit exists. Means this limiting value for a function should be a real number. But when we
Okay.
are dealing with the limit of a sequence, means
Mhm.
sequence, whether it's converging or what, then we are checking for a large value. That is, if what's the value of the sequence when n is infinite. So
Yes.
help me differentiate
Why
it.
we are doing this kind of thing? Why this kind of discrimination is happening here?
Yes, sir.
Okay. This is a nice question, basically. Okay. When I was in BSc, when I was just initially entering this kind of concept, I was just confusing it. In that question, sir, this is the function. Since this is the function, why we are calculating the limit at infinity only? Why we are not calculating at any point? Okay, it happens. Okay, it happens. Okay, let's see. See, here I am just giving you the idea why Because for that you have to understood the limit point of a set. That kind of thing is you have to understand limit point or accumulation point, cluster point, that kind of thing that you have to learn. But yeah, without knowing this point, you will understand the concept behind. Okay. Suppose I am taking a function fx equals to x square. It's a nice function, and I know the graph of this function. This graph of this function is look like this. Now, what is the domain of this function? Real number, right?
Values, yeah.
Real number means that if I will put any point here, suppose a, I know at a the limit is a square. Okay, it doesn't matter. I am just talking about the domain. If I will put any point a here, and if I will see in the aas-pados area of this a, there are infinitely real numbers, right?
Yes, sir.
No matter how much zoom I can do, no matter how much zoom I will do, no matter, it doesn't matter. If this is your a, then here infinitely many numbers. How small, how much small I can take my interval. This number
Yeah.
will be, there will be infinitely many things, right?
Yeah, we can find any real number between two real numbers, just sharpening them.
Yes.
That's
Yes. So it means that if I will, no matter how short I can do this interval, no matter how will I decrease this length, I will always get infinitely many in a real number in this interval, right?
yes,
Means
sir.
that I can approach in a continuous, I can approach is a smooth way. I can make a path like this to move towards a, right? Suppose
Yeah.
this is a path. If I want this is real line. If I want to go towards a, I can just directly make a graph smooth. I can directly take a smooth path to
Yes,
move
sir.
towards a, right?
Yeah.
Right. Now, in the case of sequence, what is the domain? Natural number 1, 2, 3. Can I make a path like this, the smooth path? Can I make a road directly? No, right? We have to jump like a monkey from here to here, from here to here.
Yeah.
You're getting my point? It
Yes,
means
sir.
that if I want to make some path, the smooth path, I am not able to make some smooth path. Okay, so there is no such way that if I will go towards left and towards right, no such concept, because I have to jump here, right? I am not going. Suppose I will take this boundary. There is no such element apart from this two for from the domain, right?
Yes, sir.
So in the sequence part, why I am not taking n towards tends to 2 and an where an will go to? It's obvious it will be a2 only, because there is only one point
Yes,
in the aas-pados area of this. Understood the idea behind it?
yes, sir. So, but what like for function, okay, for sequence, like series, we know that AP, GP, and all these things we have studied. But what's the requirement of defining this sequence then?
It's very necessary. Why it's necessary? The thing is that here, whenever you will define a definition of this limit, whenever you are defining a limit of a function, you have seen this sequential criteria. If you don't have seen, you will whenever you will learn this continuity thing, you will go by sequential criteria. Then you will, so in the domain, if this is my point is coming from domain, then we have to see if some sequence Sn going towards A, then f of Sn has to go towards L. Okay, for all sequence Sn, which are following this kind of rule, if Fsn going towards L, then we will directly say limit of f at x goes towards A will become your one. It is showing address not found. What is your address, Sena? Okay, I will let them know. Okay, just mail me regarding that. I will let them know. Okay. It's better if you mail me by after this class only. Okay. Otherwise, my memory is not so good. I just forgot many things
Okay, sir. I'm
usually.
also
Okay, so
pasting my
just send
email.
me by now. So, or just send me after this class. I will just let them know what's the issues. So you got the idea?
So rough idea got, but I think that when we are dealing with continuity, I should raise this question again there to have a
Yeah,
better.
you have to raise, right? They will explain this concept of sequence kind of function, sequential criteria of limiter.
Yeah, got it, sir.
Yes.
Thanks.
Okay. So why we are not taking? Okay. So one question is also remaining here. So sir, since here jump is there, why we are taking at infinity? Right?
Yes,
This question is
because
still
we cannot.
remaining now for sequence part. For sequence question, why we are taking limit at infinity? Here, I understood that we cannot take at any number because there is some jump kind of thing. We cannot, after certain point, we cannot move towards 2, right? It's just like there is rock. This is also rock. This is also rock. And there are some, what to say? That English movies have you seen or not? I don't know. I remember the name. But there are some fire and all lava kind of thing is there. Then you have to, if you will go here, like if you are not able to jump here, and somehow if you will want to go here some free space, you will fall in the lava. So for going from this place to this place, you have to jump like this. You cannot go like this. Okay. So apart from this step, if I will make a bridge into it, you can directly drive your car, right? But in this case, in this discrete case, you can jump. You have to jump like this. You cannot go by your car. Okay. So this kind of thing is happening. So from this example, sir, I understood the concept that yeah, we cannot we will not going to calculate the limit of a sequence at some point. But why we are taking limit at infinity? Same thing. Because if you want to suppose there are some infinity, there are some infinity. So if I will take some, if I will restrict some point, say n, okay, and then see after this point, how many elements of an are there, or how many elements of natural numbers are there? There are infinitely many. Whatever boundary you will choose, you will give me. So you will say, sir, take 10 raised to the power 24. So I can get many natural, like infinitely many natural number which are greater than this 10 raised to the power 24, right?
Sir, I
Right?
think I also need to differentiate the understanding of like a bit blurry. It's in my mind that what is different between sequence and a series, that differentiate these two. Because when we talk about series, we talk about sum, mean, and this middle term and all these sums. But for a series, we don't. So
Yeah,
if we move
zero
like
series. The thing is that for series, the series is not the topic, like series is not the it is not in your syllabus kind of thing. Say series just it's a bit complicated topic. For that, you need to understand so many things. If you are aware about it, then it's okay. Otherwise, if I will suggest you just go and watch some YouTube video, or I will let you know after this class. Basically, in the series bar, what we are doing, we are making another sequence, say Sn, and in this sequence, what we are doing, we are taking sum of the element. What does it mean? It means that series is what basically? Series is nothing but this is like this. We are summing all the elements of the sequence.
so,
Okay. So
because we are summing that came to my mind that why are we only checking the limit for a sequence, but why like we are not talking about rest of the operations that are possible with the elements of a sequence. That's why my mind went there. Like we are talking that
sorry, sir,
I'm
sorry, I
saying
did not get it.
for the sequence we are talking about only one operation till now in the lectures and
Yeah,
the discussion.
limit kind
That
of
is
yes.
when n tends to infinity, what is the value of our where
Yes.
does this series converges to? But we are
Yes.
never talking about its sum or some another type of operation that might be possible. Why is that?
Sum, what kind of sum? Like if an is a sequence, bn is a sequence, then an plus bn is also a sequence. That kind of thing you are asking.
No, like
So this,
it's a if sequence an is defined 1, 2, 3, 4, and so on. We're not talking about 1 plus 2 plus 3 and so on. Instead, we are talking only about as n tends to infinity. This series tends to infinity means it does not like that time.
1 plus 2, what does it mean? I am not getting your point. What does it mean? 1 plus 2 plus 2. See, here an is another sequence. If you will define another sequence like that, so you will get another sequence. This will not equal to an. This will become another sequence. If you will say, yeah, 1 plus 2 is 3, 2 plus 3 is 5, like that. That's what you are saying, no?
No,
That
sir.
that way, for that operation, you will get a.
Okay. Let me reframe it. Like when we have some arithmetic
Can you
problem.
give me an example?
Yeah, like for arithmetic series that is se series like
See, what you are saying. Arithmetic data, arithmetic progression. There is a basic, huge difference between progression and series. Okay. Huge difference between progression and series.
that thing I need to differentiate. Like help me differentiate.
Okay. Progression, it means that, yeah, you are also arranging some numbers, but they, between these two numbers, there are some certain formula, there is some certain pattern kind of thing in this progression. Okay.
Okay, but that is absent in sequence.
Yeah, that is absent in sequence. For sequence, we are saying it's just a number,
Okay, got it.
just a number. In just like arithmetic progression, you will say, sir, here the difference between these two number will be d. The difference between these two number will be d. The difference between these two number will be d. So basically, what is this? See,
A rule
though
is
it's a
defined.
sequence, if you will see like abstractly, it will look like a sequence. Yeah, that's true. But the thing is that there is basically two different things. The progression is just like we will discuss about what will be its nth place, what will the nth sum of kind of thing, right? And in the series is just like a special type of sequence. Okay. I think this is not the perfect place to discuss this all the thing. Otherwise, other will be confused on that. But the
Okay,
thing is, progression and series both are different. Just remember this.
okay, sir.
Okay. Okay, what's the time now? It's 10:45. Is there any doubt that you have? Please ask. Otherwise, we will
Yeah,
close this
actually, I have a
session.
small doubt.
Yes, yes.
Yeah, so basically, I was looking at 7.4 activity questions. Like I saw all the questions, and every each and one of the questions happened except the first one. So in first one, it says that a certain domain to range is defined, right? So how do you like find sequence from just a domain and a range?
Okay, let me know the question. Are you able to see the screen?
One more. Yes,
Which
the first
question?
one.
The first one. Okay. What it is saying. Okay, consider the following function where R is a set of real number, N is a set of natural number, Z is a set of integer, R plus is a set of positive real number, R minus is a set of negative real number. Okay. F1 is the function which is defining from R to R, F2 is a function which is defining from N to R, F3 is a function which is defining from, okay, this. Which of the following represent a sequence? Okay. So the answer is your F2 and F5. The thing is that here N is C. The thing is that initially they have taught you that natural number is which is starting from 0. Okay. After that, they forgot that, yeah, natural number is starting from 0.
Yeah.
Okay. So that is the mistake that they have done.
Okay. So if we are including a zero in the natural numbers, then what will be the
That
answer?
will not become a sequence. We don't know about 0th place. What is your 0th place?
Yeah,
Okay.
zero
So
is
here,
not right. Yeah.
sorry.
Yeah, could you please clarify me if n is, let's say, zero is included in natural number. Let's say they did not forget zero in the sequence. then why the first one will not be a part of sequence?
This one, F1.
Yeah.
Okay.
Like, let's
This
say it is
F1.
R to R, right? So if you can like give me an example of like a sequence that can be formed from like, these
See,
functions.
simple sequence. In the sequence, what we have, what is the definition basically? What we are trying to do by the sequence? We have some predefined places, first place, second place like this, and according to whatever set I have given, I am putting some element of this set according to that place. I am assigning some number from this set, and I am putting that number. If I will say what is our zeroth place, there is no concept of zero, right? In the place kind
Yeah.
of thing. If I will assign some our roll number, if I will assign some place, if I will assign some seat and all, whether I will write this is a zero seat, but initially conceptually, if you will see, that will become your first place only, right?
Yes, but
No
in this case,
zeroth place concept is there.
yes, if we define a set, right? So that set will be in form of Cartesian products, right?
Which
Something
set?
like A and then f of x, x and f of x type of format, right? Then how are we gonna get a sequence out of it? Are we gonna take the only the like range part of
See,
it, or
this function is your R to R, right? So this will not become your what? A sequence, because here domain thing has to be n. Now same function, if it is defining from n to r, then it will what? So you have to put the value. Just put x is equals to 1 here, then f1. This will become your first place element. Then f2 will become your second place element. Then
okay, 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 got
f3
it.
will become your third place element. That I have already explained here, no? In the beginning of the class also,
Oh,
whenever I
yes, I
was
actually
explaining.
joined the class late. Got it. So basically, it's
Just
defining the position of the element. Got it,
exactly.
got it. Okay, sir, got it. And if I can get your email address, last time in last session, you told me to send you an email regarding one of the questions that was a bit ambiguous in quiz one, but I sent the email and it bounced back.
Okay, this is an email.
Okay, I will take a screenshot of it. Okay, perfect. I'll resend you that email regarding that question that we had regarding multiplicity.
Okay. Yes, yes.
Excuse me,
Okay,
sir.
okay.
Is there any update on that one?
I don't think so. They will going to do something on it. But yeah, if we will report earlier, then because all the thing has done, right? Result is also declared and
Yeah.
all those thing is done. So if we will do something about that, the whole thing will change accordingly.
Yeah, yeah. Actually,
So it will
brought
affect
it to the
the
attention
procedure
like
of
long
that.
time ago. But they
Yes.
said that they will discuss with the professors and let me know. But I think he has still not got back to me, the other TA.
I did not get any. Sir, does it email also includes IITM? Yes, is it? I forgot the mail basically. Okay, let
Yeah,
me
I
check.
sent it to the wrong email address. I think I sent it to the IITM,
Yeah,
but they said,
yeah. Arpit study. Here you can see now.
oh yes, okay, I'll send you the email in this one. I think there is another TA who takes a few of the other sessions. I sent him, but I did not get a response yet. So that's why I
Which
was
TA?
confused.
Can you let me know the name?
Oh, I do not know the name. That's why.
Okay.
He takes some of the
TA.
sessions. Like, there is two people, right? One you and there is another one who takes few of the
We are
different.
not TA. We are not TA. TA session are different, I guess.
Oh, okay, okay. Yeah, I think the teacher who teaches the revision sessions, I
Okay,
think
say
is
Vishal sir, I think.
maybe, yeah.
Okay.
He said that he will look into it and get back to me, but I think maybe he forgot or something.
Yeah, okay, just send me an email. I don't think so. Any update will happen. Yeah, we can say like that. Yeah, that thing will happen, but we cannot change whole thing, right?
Yeah, yeah, absolutely, absolutely.
That you have to understand the things.
Yes, yes, yes.
There are some
Telecom,
concepts, like there are some. See, it's just a point. It's just a like. It's not observe. Like it's not able. We are not able to observe this small thing. It's just a small thing, right? We can easily miss that kind of mistake. Small, just a minor
yeah,
mistake.
yeah. But
So
the thing is, for that my whole question became wrong, and I went to
yeah.
92% full mark.
That's true. But if this is wrong for everyone.
Yeah, 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 yeah. It is wrong for
So
everyone.
that's
That
the
is,
thing.
but
That
I
is the
think it won't
problem.
have that much effect on even the overall grade, right?
Yeah, it won't have effect because after all the grading will be relative, right?
Or the grading will
So
be
it's
relative.
just like you can think like, yeah, if they will give you the MTA, so the MTA will give for all, right?
Yeah, yeah.
We will not decide that, yeah, this person has done, because there are 8,000 something student, I don't know how much, but yeah.
Hmm.
So we cannot go through each and everyone's option. If the options are incorrect, okay, so we
Hmm.
will give MTA. That's the thing that we will say marks to all, 2 marks will give, that will be given to everyone.
Yeah, yeah, yeah. Absolutely, absolutely.
What's the idea about it? Since
Yeah,
it's
so
a relative
basically,
grading, it will not
in
affect your
case like,
grade.
yeah, basically in case like, but the problem is with just one option, right? So it'll be hard to go through all of the
Yeah,
students. Yeah.
exactly.
Hmm. Okay, I get it. I got it. And the marks that will be given, right? So that will be like, is it relative or the percentage, like, final grade, or is it like absolute based
I
on like?
think for qualifier, qualifier only they will give like that, the
Oh no,
40%
not the
above.
qualifier. I'm talking about the final grade.
Final grade will be relative, I guess.
Relative. Okay.
Yeah, it's better to ask some TA and all. Okay, because they have also done this course, so they know
Hmm.
better about it. Okay.
Okay. Okay.
Okay, so
If
this
you
is my
can,
email, where I have forgot my
yes.
email, so please sorry about it.
Yeah, I'll send in that email. Perfect. And if you can, like, let me know who is the TA, then I'll try to contact him.
I sorry, I don't know who is the TO. That's the
Uh,
thing.
for
That's
for
why
that
I'm
for
saying.
that thing, you can just
Uh,
see your calendar. In calendar, you have two mails for the TA also. You
Oh, in
can
calendar it
ping
is
them
there.
or join in their session.
I
Oh,
don't know who is the TA. That's the thing.
okay, okay. Wait, in the calendar, how do you see the TA?
Okay, in calendar when you
Okay, let me show. Let me show. Are you able to see this
Yes, yes,
interface?
yes, yes.
Here you will find your calendar.
Hmm.
Here you will find your calendar.
Yes.
Okay, so is there any TA session? Okay, this is an TA session.
Oh, yes. So I'll just
Okay,
ask in the TA section. Got it, got it.
okay. In this TA session, I think there are some. This is created by MA1001. I guess this is your TA, right?
Okay, that
Is
will be
it?
the TA name, right? Okay.
the
I'll try
math
to.
TA email ID is not available. Sorry, it was for stats. It's available. Maths, it's
Yeah,
not
for stats
available.
is available. Yeah.
Okay,
Yeah,
you
maybe
just
I'll just
join in
find
this.
that.
You
Yeah.
just join in this session.
Hmm.
You will get them.
Yes, 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 yes.
Okay.
I'll
There are
do
so
that.
many TA session. I think tomorrow is there is no TA session.
Okay, I'll just
Okay, it will be
join
on
and
Wednesday.
yeah,
Wednesday.
because if it is relative, then it will be like much more easier. Yeah, but absolute, yeah, sometimes it causes problem. Hmm.
Uh, sir, could you visit the sixth question on this same activity, please?
Sixth question.
Yeah, in this,
This one.
yeah, I have just specific doubt. Like, there's a rule of like conversions for related to sequences that says
Mhm.
that if N converges to A, then the and
Mhm.
C is a real number, then C to the
Mhm.
power A, C times N converges to CA. So the answer should be 3 according to that rule.
What does it mean? Basically, you are saying correctly. You are saying, sir, okay, if F, uh, if Sn is equals to something, Sn is your function sequence, and Sn converging to A as n goes to infinity, then 3 times Sn will go towards 3A, right? This is your option, right?
Yes, sir. Yes, sir.
So here, sir, An going towards 1. Why A3n is not going, why 3n not going to 3? See, here, this is A3n. It means that what is it? What this is a subsequence of this sequence. If you
Oh,
are
yeah.
able to
Got
see,
it. Got
this
it.
is
Got it. Got it.
subsequence. This is your A3,
Hmm,
A6,
hmm,
like that.
hmm. Got it, sir. So, one like 7 point activity 7.1 question number 11, please.
7.1 question by 11. Okay, others, they can leave, okay? Okay,
Okay,
question
sir.
number 1,
11, sir.
11. Okay,
For
this is
this,
what
for
is.
for this question, is seeing the graph, it's quite easy to see that
Yes.
what is a valid thing and what is not. But
Mhm.
analytically, how can I see that? And one more thing, like in the given answer, it's marks that option 2 is correct. But if we see
Okay.
that a natural number also includes 0, then this
Mhm.
function is not defined at 0. So how can it
Okay.
be like part of the domain?
Okay. So basically, you want to see if you are dealing with the graph, then it is easy to see. But if I don't want to make the graph,
Yeah, how can I?
what is this, Suraj? Asit sir and Muhammad Nayak. Oh, TA's name, right? Okay.
Yes,
Okay.
sir, they are a T name.
Okay. Okay. So just see the first option. What it is saying? F is injective function if the domain of F is r minus 0. So it will be r minus 0 only, right? Because the 1 by x thing is not defined at 0. So it will be r minus 0. So it's a 1 function he is asking for. Checking 1 function is not or not. There is one way to check this, right? Fx is equals to x plus 1 by x. This is. Okay, suppose it's not a 1 function. So there exists 2 point x1 and x2 which are not equal to each other. And for that, your fx1 and fx2 will be equal to each other.
Yes, sir.
Suppose not a 1 function. So what it will be? X1 plus 1 by x1 is equals to x2 plus 1 by x2. Yes, sir.
Hmm.
Okay. So
We cannot.
since if you will take gx is equals to, okay, if you will take gx is equals to, what to say? Okay, let's move further. It will become x1 minus x2 and what? 1 upon x2 minus 1 upon x1, right?
Yes, sir.
Then x1 minus x2. This is equals to
X1 minus x2
x1
divided by
x2
x1 x2.
x1 by x2 x2 minus x2. No, anyone like this will not become 0. This will not become 0. This will not become 0. X1 minus x2. If I will take this side, so I will get 1 minus x1 x2. Okay, so what is equals to 0.
No,
So
sir,
there are only two ways.
sir, why don't I move towards canceling? Like,
I
it's
cannot cancel, right?
it's numerator, na? Numerator is x1 minus x2, and on the right hand,
Yeah, yeah, you are correct. But here it will be plus.
it should not be like in the second last sentence. It should be x1 minus x2.
It's
Second
correct,
last.
right?
Yeah, right. After taking the this numerator of x1 x2.
Yeah, it's x1 minus x2. Yes.
Yeah.
So
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 now
it,
numerator of both the sides are same.
no, we are not going to cancel because there, see, if you have a question like the x square is equals to 2x, and I want to find the roots, whether I am canceling this 1x, 2x, this
Yes,
cancel and
sir.
x is equals to 2 is root. No, right? Because
Yeah.
x equals to 0 is 1 is the possibility.
Yes, sir. This is 0, this is 0. Okay.
Okay. So since I have here I can take, see this is not equal to 0. So here we can cancel because I am taking this is not equal to each other. So this will cancel out. So from here what we will get 1 minus this x1 x2 has to be equal to 0. This is the only way for becoming this kind of thing equal to 0, right?
Yes, sir.
Because this thing will not equal to 0. Okay. What we can say 1 upon x1 into x2 means that x1 into x2 is equals to 1. So it means that if I will choose x1, x2 like this, x1 is equals to 1 by x2. Okay, then this function will not, you will get, uh, you will get 2 points. For that the function value will be equal. Okay, so just take x1 is equals to 2,
And x3 equals
then
2,
x2 is equals to 1 by 2.
Yeah.
right?
Hmm.
Then what it will be?
I
F
will
of 2
still
is
functional
what?
value.
2 plus 1 by 2. And
Hmm.
f of 1 by 2 is what? 1 by 2 plus 1 upon 1 by 2, which is equals to 2 plus 1 by 2. Not 1 function. For two
Mm-hmm.
distinct values, we are getting same. Not a one.
Yes, sir.
This is a like you don't need to do this kind of thing in exam. Just try to see, just try to find two distinct point for which this function value are equals. So for observation, you can directly find, right? X
Yes,
plus
sir.
1 by x is there. Some kind of symmetry is looking like if I will put some x equals to 3 here, 1 by 3,
Hmm.
here 3, and 1 by 3. So I can see like that, right? 1 by 3 plus 1 upon 1 by 3. So it's just an observation from that you can directly find the answer. Oh, it will take some time, right? You need to do more practice on into it.
Okay. So for the option two of this question now, solution is means the key showing that option two is correct. But if we check at x equals to 0, then this becomes 0 plus 1 by 0, and 1 by 0 is not defined. So function is also not defined. So why is it this?
Okay, here also this n is your natural, which is starting from 1, 2, 3, 4. Okay. I
Mhm.
don't know why they are including 0 before. Yeah, that one reason is behind it, right? For your calculation purpose. Like, so many things are incorrect.
So the
So
thing
one
is
reason behind it.
in
Okay,
that.
here they are starting from 1. Okay.
Okay. So the thing is, when we started with the week one content, now there the natural number was specially defined from 0 to 1, 2, 3.
Right.
So in our mind, whenever we see symbol n or anything, even the factor that rational number z anything, first thing came that whether the zero is part of that or not.
Yes. So basically, if they are just talking about natural number, definition of natural, real, that kind of thing. So just make sure that yeah, the 0 is including here. Okay. And if they are not mentioning the thing, like in the exam purpose also, they are defining a function which is defined from natural number to some real number set. Just make sure that that natural number is starting from 1 only. Okay.
Okay, sir.
1, 2, 3, 4 like that. 0, they are not going to include. Yeah, we will remember this kind of thing. Yeah, in the activity question, you can do like that. But further, whenever we will make some question from that, we will make sure of that kind of thing that, yeah, 0 will be included or 0 will not be included in that.
Okay, sir. So
We will see.
can you also frame these sentences like the one that you used to solve this question, that if x1 is not equal to x2, that means the implies that f of x1 is equal to, if it implies that f of x1 is equal to fx2, then this means that it is an injective function, that is one-to-one function. So this type of statements a few questions has used. So could you like collectively uh, mention them that this is the
Um,
specific condition for injective, and this is the
yes,
specific condition for the function.
I think that we have I have covered in previous classes. You just go and watch that.
Okay, sir, I will reference it there then.
Yeah, I have already covered this injectiveness and subjectiveness. What are the main things are inside it? So this is very trivial.
Yeah, it's trivial, but when it came to function, that there comes a confusion point sometimes, that should we means in this type of implication statements, like if we say that if x1 is equal to fx2, should we consider that fx1 is equal to fx2 or not, and this type of thing. I
See,
will reference it.
here what I have done here, basically, I just contradict the statement. I was saying that suppose it's not an injective function, then since it's not an injective function, then for two distinct x1 and x2, there exists some distinct x1 and x2. For that, the functional value is equal, right?
Yeah,
If this is
but
not a function.
sir, but from like horizontal line test, we know that if f of x1 is equal to f of x2, that means if we are able to get any x1 and equal to x not equal to x2, that also proves that it is not a one-to-one function.
Yes.
So because of that, I need to see some collective, like because that's true, but is it always universally true?
Yes. Horizontal line attached to you if you are in the domain of definition. If something is your function and horizontal line is cutting into two points, what does it mean? It means that since if I this is your point, this is your point, so here you are getting same value, right? This value will give you your functional value. So here you are getting same value for two distinct points. Means that this is not a one-one function.
Yes, sir. So if I write f of x1 is equal to if for f of x1 equals to f of x2, implies that f x1 is not equal to x2. That means it is not a one-to-one function.
What you are saying, fx1.
F of x1 is equal to f of x2 implies.
And here from here you are getting that x1 not equal to x2.
Yeah.
Not implies, but yeah, for this x1 and x2, you if you are for these two distinct x1 and x2, you are getting both things are equal. So this will not become your function.
Okay.
One
So
one.
the thing that use the not condition, is that universal?
Yes.
Okay. Because this
So
becomes a
if you are
subject.
not, if there is some doubt into it, just I'm saying just go and watch that lecture where I have explained all those things. Like there was some doubt in the definition itself. So
The
that I have
definition
covered.
the
Just
definition thing is clear for me, but
no,
I
there
also
is there are some negation part of that definition as well, right? So they will
okay.
confuse some of the will be confused in the definition itself. Just
Hmm.
go and watch, that's the thing.
Sure, sir. I will just tell you with that. If I like stuck somewhere, I will let you know that. Okay. Thanks, sir.
Okay, I am stopped. Okay, good night, guys.
Good night, sir. Thank you for the session.